Collision in one dimension. Consider first a completely inelastic collision in one dimension. Then in figure, theta 1 is equals to theta 2 is equals to 0. So m1 v1 I is equals to bracket m1 plus m2 bracket close into vf from momentum of conservation. So vf is equals to m1 into v1I upon m1 plus m2. This one is equation first. The loss in kinetic energy on collision is delta K is equals to half m1 v1I square minus half bracket m1 plus m2 into vf square. Now using equation first, we will replace vf in this equation. So delta K will be equals to half m1 v1 I square minus half m1 square v1 I square upon m1 plus m2. After solving this, we will get delta K is equals to half m1 v1 I square into bracket 1 minus m1 upon m1 plus m2 bracket close. Further simplifying this equation, we will get delta K is equals to half m1 m2 into v1 I square upon m1 plus m2, which is a positive quantity as expected. Consider next an elastic collision using the above nomenclature with theta 1 is equals to theta 2 is equals to 0. The momentum and kinetic energy conservation equations are m1 v1 I is equals to m1 v1 f plus m2 v2 f. This one is equation number 2. And m1 v1 I square is equals to m1 v1 f square plus m2 v2 f square. This one is equation 3rd. From equation 2nd and 3rd, it follows that m1 v1 I into v2 f minus v1 I is equals to m1 v1 f into v2 f minus v1 f, or v2 f into v1 I minus v1 f is equals to v1 I square minus v1 f square. That one is equals to v1 I minus v1 f into v1 I plus v1 f, because we know that a square minus b square is equals to a minus b into a plus b. So v2f is equals to v1I plus v1f. This one is equation number 4. Substituting this in equation 2, we obtain v1f is equals to m1 minus m2 into v1I upon m1 plus m2. This one is equation 5. And v2f is equals to 2m1 v1I upon m1 plus m2. Thus the unknowns v1f, v2f are obtained in terms of the knowns m1, m2, v1I. Special cases. Case 1. If the two masses are equal, v1f is equals to 0 and v2f is equals to v1I. The first mass comes to rest and pushes off the second mass with its initial speed on collision. Case 2. If one mass dominates, that is m2 is greater than m1, then v1f is approximately equals to minus v1I. and V2F will be equals to 0. The heavier mass is undistributed while the lighter mass reverses its velocity.